So yesterday there was a question. The question was how we can define a function where it can take all the all the numerical types, a generic function. I mean, there is no a straightforward way to do such a thing because we only have range. So suppose there is a type A and there is type B, you can only specify in this fashion. So there is one is any type, any value, other one could be something else. I mean, there is no straightforward way. We can see it here. How about now? Is my voice clear, audible and clear? Yeah. As I was saying, we want to do some numerical operations, addition, plus, minus, and we want to define a simple function where we can restrict to only numerical operations. We don't want to pass any other operations. There is not a straightforward way. I mean, we cannot. It's nothing like if you see double is not a super type and byte is not a uh, subtype where we can range from here to here. We cannot do that because byte is not a subtype of short nor it is a subtype of others. So we cannot do that. If I specify a range from any value, it should be a subtype of any value. That's the main thing we can do. I mean, I can say pass anything. I can define an operation pass any type that is subtype of any value. So I can do this operation. I can specify x is of type A, y is also of type A. But that will also include unit, boolean, character. These stuffs also it will include. But other than that, there is no other way. They have provided some other way. Even that is also not at the compile time. You cannot give an error if you pass a totally different type during the it cannot give error at the compile time. It is also giving the error at the runtime. Here also you will get the error at the runtime. That the other way of doing that is they have something called as numeric here. From the Scala library they have numeric. So this numeric function has this plus method, minus method, all this stuff. So we have defined a function. I have defined a function of type A. X is A, Y is A, and there is something called as implicit. So we need to understand this implicit, only then we can understand the whole example. But this is also one more way where we can achieve numerical operations here. I will explain this later once we understand implicits. Once we understand implicit. Other than that, there is no other way to define a function which only takes numerical values. This is the good way. I hope that was clear. and I will explain this later because it involves some other concepts to be learned. So getting back to the normal session, so we were talking about functions are also objects because Scala is a pure object-oriented program. Functions are also internally treated as objects, and we as a developer can also create a function objects. Some of the use case of function objects is that we can treat them as objects itself, just like we do some pass an object as a parameter to a function. Now a function can also be passed as a parameter to a function. Functions can also be passed as parameters to another function. So this itself is called as a higher order function. You can also return a function from a function, that is also called higher order function. Return a function, because function is just an object. It is as good as saying as an object is being returned here. Return a function from a function. So that is also called as higher order function, but mainly our concern is this. And why do we need higher order function? These are the questions. Why higher order function is required? All these questions we will answer, but first we'll start with how to represent a function object. First we'll start with what is the syntax. What is the syntax for function object? There has to be some function of syntax. So let's understand that, because with the help of that we will be trying to define higher order function. Then we will be seeing why higher order functions are required. So I will try to give the syntax of a higher order, a function object by comparing it with normal objects. Let's compare and define the things. Let's say I have x is equal to 10. Let's say I have y. I will explicitly specify the type as int, even though it is not required, which is not mandatory. I'm just specifying so that I can explain how a function object is created. And I will assign x to this. An object is being assigned to another object. A value has been assigned to an object. Now x is assigned, hence y data type is set as integer. We cannot say y as string. We cannot say this. We are specifying integer because we are assigning an integer to y. So that we have to keep in mind. So this will not work. So keeping this in mind, let's see how a function object can be created. We know that this is how objects are created. Whenever we say val x is equal to 10 or val y, this is the syntax of creating an object. Function object syntax should also be in a similar fashion. First we'll take this syntax, and correspondingly we can show how it looks for a function. So what I can say about the syntax is, already a value is been defined, already x has been defined, and that x has been assigned to y object. we have already defined x, and that defined x is now being assigned to an object called y. So in a similar fashion, let us define a function. Let's say the function name is doubler, which takes some value, and let's say we multiply it by 2 and give the a simple function. It takes integer and it multiplies it by 2. It doubles the value. Whatever value you give, it doubles it. That's your simple function. This we can compare it like x is already defined. X is already defined here. Here also a function is already defined. Now we'll create a function object so that we can assign this doubler to that object. We can assign this function to this object the way here it is being done. We are defining y and we are assigning x. So I can say it will follow the same syntax val. I can give anything here, any name. I will just say for readability purpose, I will say my doubler. Then I will specify the data type. Just like int is being specified as the data type, because we are assigning an integer to that. I shall be assigning this function. I shall be assigning this function to this object. So we need to specify the function's data type here. Now what is function data type? This is a new thing. What is function data type? Any guess what could be the function data type? Function data type, the syntax for that is it is actually input data type and output data type, not just the return data type. It is input data type, and the syntax is this: an arrow mark, and we have return data type or output data type. So this is a function data type. Data type of like integer is a data type, double is a data type, string is a data type. Similarly, a function also has a data type. Anybody has a question here? I mean,
Like the function name should come, the function name and the input parameter type and the return parameter type,
the function
right?
name will not be there. It's only the data type we are talking about. So we can compare x, y is the name. Y is a name here. Similarly, my doubler is a name here. We have to specify a data type. Int we are specifying the data type. Here also we need to specify the data type. But since I shall be assigning a function to this object, so I need to specify function data type. Here I'm assigning an integer, hence I'm specifying integer data type. So it will be, what is the data type of doubler function here? Input data type is integer.
Yeah.
Return data type is also integer, because multiplication of an integer with 2 always returns an integer. So you can see that we are following the same pattern. Val y colon int. Here we said val my doubler colon int arrow mark int. Then we have to actually assign the value. Here x is been assigned. Here doubler can be assigned. I mean, I can assign any function. Any function, just like I can assign val y is equal to int. I can assign any other. I can assign z also, provided it is an integer. In a similar fashion, I can assign any other function also, provided that function takes an integer and returns an integer. Yeah, here is a question. The question is, here we are having only one data type, only one parameter. What if we have more than one parameter? We will see that. We will see that as well. So now this is called function object because it is because it's a function. It's an object which is pointing to a function. We call it as a function object. So I hope that was clear how to create a function object. This is how we create a function object. An object specify the data type, in this case the function data type, and we know what is the function data type, and assign a function to that. So I can say, if I put it here, so I will define a function doubler. This is a simple way of defining a function. We'll say integer, and it returns x star. A simple function which takes an integer and it returns an integer. Now if I want to create a function object, I will just say my doubler. Specify the data type as int arrow mark int, and then assign doubler to that. So now it means that this is a function object. Now since this is an object, I can just say val abc is equal to my doubler. This is an object. I'm assigning this object to some other object. Now this object also becomes function object. I can just say val xyz is equal to abc. Now this object also becomes a function object. Then if I want to actually call that function, I can do this fashion. So this is how you define a function object. So I hope the things were clear. Our main idea is to understand higher order function. So higher order function requires a function to be passed as a parameter. If you want to pass a function, it has to be in the form of an object. So hence we are trying to understand function object. What are the syntax to create a function object? So this is one of the syntax to create a function object. So this is one of the way to create a function object, comparing it with this syntax. Now we need not define the function. We need not define this function and then assign this function to the object. We can directly create a function object. We need not define a function and then assign it. Just like this. Just like this. Nothing has been assigned to this. And we don't have an already existing some z or something, and we are not assigning that z to x. We are directly assigning a value to x. We will see one more syntax of creating a function object, which in which we can get rid of defining a function and then assigning. We can directly create a function object. To understand that, we need to know some more things. So the syntax will be val x equal to 10. By this syntax we'll be creating a function object. We will be following the same syntax. So we know that these are all called as values. This is an integer value. This is a double value. these are all called as values. Integer value, double value, string value. Now what we can do is we can give a name to this value. Whenever we say x is equal to 10, we are giving a name to this value. X is a name given to this value. Whenever I say y is equal to 2.5, we are giving a name to this value. Similarly, whenever I said z is equal to this, z is the name given to this value. So we can have a perspective of such a thing, that a name is being given. Whenever we say val x is equal to 10, a name is being given to the value. Now there is one more jargon called as literal. Now what is a literal? Literal is nothing but one more name for values. Literal is nothing but one more name for values. This is 10 is called an integer literal, 2.5 is called double literal, Scala is called as a string literal. So now what we can say about a literal is nothing but a literal without a name, a value without name. Anything without a name, anything without a value without a name is called as a literal. Literal is some value without. So I mean to say, if you remove this, we get this 10 literal. If you remove this, we get 2.5 as a literal. If you remove this, so if you are removing means we are taking out the name of that literal. So literal is some value we can say without name. In a similar fashion, what we can say about function literal is some function without name. That's what we can call with a function. Function literal is nothing but a function without name.
So it's an anonymous function.
Yeah, the one more name is called that as, because there is no name, we say it as anonymous. Since there is no name, we call it as anonymous function. So how do I? So I have a function, let's say we had this doubler function, right? Takes some integer and it says x star 2. Now a function literal is some function without a name. If I remove these things, so this whatever is remaining is called as function literal. Now we can see that we can compare these two things now. The way an object is created. We said val x and assign a literal to that. This is a literal. This is how a simple object.
Even the body part can be written instead of equal to, we can write within the curly braces, right? Block.
Yeah, we can have a block of expression. Any number of code we can have. And that is called
No, without equal to.
Yes, without equal to, but here the syntax is slightly different. Here we have to have a syntax, and this syntax is, when we define it as a function object,
Okay.
we have to have the syntax. So just like whenever I say val x is equal to 10. What we are doing here, we are assigning a literal to an object. Assigning a literal to an object. Similarly, if you assign a function literal to an object, that becomes a function object. If you assign a function literal to an object, that becomes a function object based on this pattern. So we need not define anything. Let's say I want to have a tripler function which triples the value and gives it. So if I want a tripler function, how it will look like? So if at all I would have defined it, even though it is not required, which takes something and it says x start. So this would have been our function literal. This is our function literal. So I need not define this tripler function, directly assign this literal to a function object. It becomes to an object it becomes a function object. I can say tripler equal to because this is how we assign it. Val we I'll just compare it with this. Val we say x equal to 10. I will use the same pattern. Val my tripler equal to an object, here also an object, then assign a literal. What is that literal? Just to avoid the confusion, I will specify a takes int arrow mark a star. So this is our function literal, right? We can check it here. Some parameter arrow mark, that parameter star 3. The same thing we are doing here. So either we use that syntax or we use this syntax, and this is how we achieve a function literal. So again, you can just, once we got an object, we can say val abc, anything, val abc is equal to my val efg is equal to abc. We can call this function and pass any value to that. It will multiply it by 3 and give the result. So the idea here is you can create a function object like val assign the function object here, takes a int, and here is the logic. Either you do in this fashion or you specify in this fashion. You might have already defined doubler, which takes integer and returns a star. So you define val my doubler, specify the data type, takes a int and returns a int, and assign the doubler. So this is a function object. This is also a function object. So this is how you create a function object. So this corresponds to this, and this corresponds to this. Now there is one more thing associated with the function object. There is some shortcuts available in the function object. That shortcut is nothing but you need not specify the input parameter. You need not specify the input parameter. I mean, there is no logic behind that. Why, how they have come up with such a thing. I gave the logic how function literal is or anonymous function is, how a function object can be created. There is a logic behind that, but the one I'm going to tell now, which is a shortcut, I don't have a logic for that. I mean, there is no logic for that. You have to just intuitively keep this in the mind. It is a shortcut. The, the what the shortcut says is the input parameter need not be specified. Instead of that, we can have just underscore. We can place an underscore as a placeholder. I mean, we can use the underscore as a placeholder for the input parameter. So what I'm trying to say here is I can just specify val my tripler, specify the data type. It takes an integer and it returns an integer. And you can specify, instead of the input parameter, I can just specify underscore. Underscore is nothing but that input parameter. We need not specify the name, we just use the underscore. This is a shortcut that is being used here. Instead of specifying a star 3, I just specify underscore star 3. This is a, in a similar fashion, I can also specify my doubler, which takes an integer and returns an integer, and the definition is nothing but that input parameter can be, we can have a placeholder for input parameter as an underscore, and we can just say underscore. So whenever I say my doubler of 3, now 3 is there in the underscore. Underscore represents that input parameter. So it will just multiply underscore with 3 here, 3 into 2, it will give that. So this we need to keep in mind. This is a shortcut, and you cannot apply the shortcut everywhere. The shortcut has a limitation. The shortcut has a limitation. Now, if I want to create a function object, I want to create a function object for something like product. So I have function called product, which takes this is my function object. Sorry, this is my function. How can I create a function object for this? I mean, I can create in multiple ways. One is through data type, and one is through function literal. So we know that this is a function literal. We can just say val abc equal to x star y, or we can say val efg specify the data type. Now what is the data type of this function? The data type of function is it takes two integers and it returns an integer, because multiplication of two integers is always a integer. The data type is this, and it returns an integer, and I just assign product to that. So either I define in this fashion. Both are function object. Or we can use a shortcut also, where I can say val element equal to, the shortcut version, define an object, specify the data type. I can, instead of assigning here, I can use underscore star underscore. Now first underscore means the first parameter, second underscore means the second parameter. So that's how we can define a function with multiple parameters. And if you are using an underscore to achieve the shortcut, the ordering is important. The first underscore will always represent, it is a placeholder for the first parameter. Second underscore is always a placeholder for the second parameter.
This is a definition or it's a...
This is creating a function object. This is the shortcut version.
But we didn't define any equal to product, any function name. So
Right.
underscore into underscore, it's like a definition, right?
Correct. It's a definition. It's just like, you can imagine this. Instead of
Yeah.
x star y, we are just saying underscore star underscore, where underscore, first underscore is x, second underscore is y, we can imagine.
Good night, Amma. I'll talk.
Sorry, somebody had a
Pramod, actually in the first line you mentioned val abc equal to, next line you mentioned as cfg colon.
correct.
So does it matter? I mean, is it interchangeable or any specific thing, like for this you need to use equal to, for this you need to use
Right.
colon?
Whenever we say val, here we are saying efg, we are specifying this is the data type of the function, because we are assigning this function. If I just say, let's say I have defined a function, I have the doubler function. This is how I call a doubler function. Now if
That
I
is
say,
the data type of the variable EFG, right?
that's the data type of the variable efg.
Variable EFG, and you are assigning a function.
Correct.
Okay.
Now if I say, I will also define product here, which takes x int, y is also int, and I will just say x star y. Now if I say val efg, if I don't specify the data type and I just say product, now what the compiler will think now is, we are trying to call the function, and after calling the function, whatever return value we get, that is being assigned to EFG if I don't specify the data type. Because usually we write in this fashion, right? 3, 4. So in this case, what happens? We are calling this function with 3, 4. It will multiply 4 into 5. 20 will be
So it
returned and
is an
assigned to
integer.
EFG. That's how the compiler will think. If I do without specifying the data type, if I do this, the compiler thinks that we are trying to call the function and the return value will be assigned to EFG. But while calling the function, we are missing the two parameters. So that's what the compiler will think like. Now if I specify the data type here, like it takes two integers and returns an integer. If I specify this data type, now the compiler knows that this object is a function object. This object is a function object, and we are just trying to assign a a function to that object. We are not calling that function, we are just assigning. So in such a case, whenever we are trying to assign any already defined function, if you are trying to assign any already defined function to an object, in that case, the data type is necessary. Because otherwise the compiler doesn't know what we are trying to achieve, whether we are trying to call the function or whether we are trying to assign the function. So whenever that's the thing we have to remember, whenever we want to assign an already defined function to an object, the data type is necessary. Now here the data type is not necessary because the compiler knows that this is a function literal. Hence the data type is not at all necessary here, because this syntax, through this syntax, the compiler knows that this is a function literal, hence data type is not necessary. The data type will be automatically inferred by the compiler because there is no ambiguity as such. So in this case there comes an ambiguity, hence specifying the data types becomes mandatory. So I hope Kalan that was clear.
Yes, Pramod, thank you.
So last two statements are same.
We can say that this is a shortcut way. I mean, initially it may be a bit confusing, but as you keep on writing the program, it will be integer. This is a shortcut way. All are
Okay.
same. Everything is nothing but creating function object.
Correct. But if the function has some other logic instead of x into y, so we cannot assign like this, right? A dash into dash.
Correct. That's what I was trying to say. The underscore has limitations. You cannot use underscores everywhere. Only if you have a single expression. If your body, if your function body has only single expression and non-repeated identifiers or non-repeated parameters, if there is no repetition, only then we can use underscore. So what I'm trying to say here is, let's say I have a function called square.
Like x into y into x. So we cannot define, right?
Correct. That's the example I'm trying to give. I have a square function which multiplies x star x. This is a square function. For this we can create a function object also. I can say val square 1, I will say square 1, and I will just specify the data type. It takes integer, it takes an integer. Square of integer is always an integer, and I can just say assign square to this. Now square 1 is a function object, or I can also say val square 2. I can just assign the function literal here. This is our function literal. I can just assign that function literal. Only thing is arrow mark will come here. This is also fine. But I cannot use the underscore here. I cannot create function object 3, specify the data type as takes int, You can also use parenthesis for single parameter also, but it's not mandatory. Here I cannot say underscore star underscore, because as I said, underscore represents the order of is a placeholder for the parameters, and the order is also there. Here the compiler thinks that underscore is first parameter, second underscore is second parameter. It is expecting a function with two parameters, but this is a function with only one parameter. So that's where whenever you have a repetition, you cannot use the underscores. That is one. And whenever there is multiple block of expression, if your function is not a simple function, there are a lot of lines in your function, even then the underscore doesn't work. So those are limitations of the underscores. Only if it is a single expression, and even in single expression there has to be no repetition. If only such things can in such things we can use the underscore. Otherwise we cannot use the underscore. So this is how you create a function object. Either you create a function object in this fashion, either you create a function object in this fashion, either you create a function object in this fashion. Now we'll make use of these things. Now we have just defined an object. Now what is the use of this object now? That's where we'll try to understand what is higher order function. We learnt about
For example, value SQ2 equal to
yes, Thiru, go ahead.
the value SQ2 equal to this one, right? So the statement. So it is equal to means it is the return value is assigned to the variable,
No,
so to the identifier SQ2 or
no, not the return value. This is a function literal. A function literal is itself assigned to SQ2. Now we can
okay.
call SQ2. I can say val result is equal to SQ2 of 4. I can say SQ2 is a function object now.
Oh, okay.
So it will do the square and it will return and assign that square to this. All these
Right.
are function objects.
Okay. That's a function literal.
Correct. This is a function literal. Without
It's a little confusing.
right. I mean, it's a function literal. So either you define, the idea here is to create a function object. This is one way of creating a function object where a function is already defined and you just assign that function to an object. So you need to specify the data type in that case. Or you need not define a function, you can directly use the function literal. You can directly use a function literal and assign to an object. It becomes a function object. And the same thing, we are creating a function object with some shortcuts. We can use it. Here the shortcut doesn't work. In this case, the shortcut doesn't work. But our overall idea was to create a function object. The syntax, our idea was to learn the syntax to create function object. Now we need to use that function object. The usage is to create a higher order function. Now what is a higher order function which is of importance to us? The higher order function is a function which takes a function as a parameter. So if I say, let's say I define a function product. This is how I specify the input parameters. And I have my body of the function, x star y. Now this is a traditional way of defining a function which takes two integer parameters, and in the body we are multiplying those integer parameters. Now if you see, this is how we specify the parameters, x int y int, because we want to pass integer values to that, 4 and 5. Now I want a function to be passed as a parameter. I don't want normal values to be passed as a parameter. I want to define some other function. I'll just say string ops. I want to pass a function as a parameter. Now, since I want to pass normal integer, I need to specify the integer parameter here. Similarly, I want to pass a function, so I need to specify the function data type. Here I have specified integer, now I need to specify function data type. So I mean to say, I will just say string ops. I want to pass, first parameter I want to pass a simple string. So I will say the data type as string. Now the second parameter what I want to pass is a function. Second parameter I want to pass as a function. So I need to specify function data type. Since I want to pass string here, I'm specifying string data type. Here I want to pass a function, and I need to specify the function data type. Now what kind of function I want to pass? That also we need to know. If you want to define a data type for a function, it gives you the what kind of function you want to pass. I want to pass a function which takes a string and it returns a string. Such kind of a function I want to pass. So if you see here, I cannot pass a double value here. I cannot say 4.5. I cannot call the function with 4.5 and 6.5, something like that. It will give an error because we have defined it to accept the integer. We have to pass an integer. We cannot pass some other data type. Here also the same thing. We have defined the second parameter to accept a function that takes a string and returns a string. We cannot pass any random function. We can only pass such kind of a function which takes a string and returns a string. Now why do we pass parameters? So that we can make use of those parameters in the body. X and Y we are making use in our. Similarly, S and A also we should be making use in our function here. So A is nothing but it's as good as saying A is a function object. We can say in this fashion. We have just specified a object and we are giving a data type. We are giving a data type. So A, whatever we pass as a parameter, that will be assigned to A. A will be looking as a function object now. Now we can just define something. If S is equal to, if S is not equal to null, something. I can just call this function. A is that function object. I can just call this function, but the only thing is it expects a string. I can pass any random string here. I can just say Scala, anything. But we also know that we already have S here. S is also a string. I can pass that string here. Else I will say just return that string. So this is called as a higher order function. So higher order function is a function that takes one more function as a parameter, and we make use of that function inside the higher order function definition. So just let's try to define this. The first parameter is a string. Second parameter, you can have anything. I mean, let's give for more readability purpose, I will define the parameter name as f. I will define the parameter name as f. F means is a function object, and we need to specify the data type, what kind of function I want to pass. So I want to pass a function that takes a string and it returns a string. And that function I shall be using in the body of my higher order function. And I will say if s is not equal to null, I will call that function. Any logic you can specify s and pass the s as the input parameter. Else return.
The thing is, we can define the function outside, right?
We can right. That's the idea. Any function you can pass.
Yeah.
Any function that is defined outside, we can pass it as a
Can be
parameter
passed.
to this. But only thing is the data type has to match. So let's say
Right.
I define a function called. Let me check. There was one more question. Should the function be
It
already
is
defined?
kind of an injection.
We can say that it's kind of a generalization. We can say it's more a generalization.
Yeah.
We will see why we are defining a higher order function. Now here is one more question. Should the function be already defined? Not necessary. I mean, are you asking about the higher order function or the function that we need to pass as a parameter? The function that we need to pass as a parameter need not be defined already. We can define it later also, as I'm defining it now. So I will just define a function. I will just define a function saying
Okay.
define convert to upper. This function takes a string, and on the string there is a method called toUpperCase. This is a method inside on the string object. So it will just convert a string to a uppercase. So we can check this. Convert to uppercase. Pass. It takes a string. Pass Scala. We can see that it will return Scala in a uppercase form. So as you can see, this function takes a string as an input parameter and it returns a string as the return data type. So obviously this function's data type matches here, this parameter's data type. Now obviously we can pass this function as a parameter. String ops, I will just say
Any function that takes a input as string and return as string will match that.
correct. Any function which matches this data type, you can pass as a parameter. Convert to upper. It is as good as saying val f string to string is equal to, it is as good as saying this. Now f becomes the function object. We are just calling f with anything. It will. It is as good as saying this. Whenever we are passing a parameter, a function, it is f is holding that function now, and we are calling that function with any parameter.
Right.
So this is what we call as a higher order function.
We didn't know what is the actual definition. So f of Java means like it's already been assigned the function of type.
Sorry, Thiru, I didn't get your question.
No. Actually, f of Java returns the uppercase. Actually, while passing that value, we didn't know what is defined in that actual function.
Right, right. We didn't know that what is defined inside that.
Kind of.
Sorry, your voice is breaking. Just a second. There is audio connectivity problem. I think the audio is restored. Yes, Thiru, go ahead.
Sorry, I mean like so we are not giving the actual definition. So we are assigning to a variable, and it's like kind of a encapsulations. We are just passing the value, but the actual definition has the functions within that.
Correct, correct. The actual function is called here. We
Yes, right.
define this function, and we are passing that function as a parameter,
Right.
and that function is actually called inside this higher order function.
Yeah. Right.
So I'm just this you can forget, because I just wanted to compare this. I mean, whatever
Yes.
I'm saying is, it is just a similarity here. So we also know that we can directly use the function literal.
Yeah. If we directly use the function, we will know. But if we assign to some other variable, and through that variable, if you passing, then a lot of information is hidden.
Hidden in the sense, if you already know the function definition,
Yeah.
then it's fine. I mean, we know that
Yeah.
we have defined convert to uppercase.
Right. Yeah.
We have defined this, and we will be passing the same function. Now we know that.
And similarly, we can have another function also, right, which takes a string and returns a string. We can also use that.
Right, anything
And
that,
pass it
takes a string and returns a string, any such function can be passed as a parameter.
Yeah, even that the function itself is like kind of a reusable
Correct.
code.
So that's the main use of a higher order function. That's the main use of the higher order function. This could be reused for many other purpose. With
Right.
a few lines of code, we can achieve lot of things here. That's
Right.
the main use of the higher order function. Now here I can directly use we need not define this function. We need not define
Correct.
this
Yeah.
function. We can directly use the literal of the function
Correct.
and directly use this. This is my function literal, which will give you the same result. I can directly use without passing, instead of passing a function. It is as good as saying if val f equal to
But here we cannot change any definition because we have a fixed. We have defined it, the
correct,
definition in that itself.
correct. I mean, we can.
That is more abstract. That is more abstract. Taking a string and then returning string is more abstract. Again, later on we can define our own function, different functions to take a string and then return a string. Kind of abstract function.
Yeah, here also we can pass any function literal.
Yeah, we can pass, but here.
Which takes a
Okay.
string and returns a string. Here also
Right.
pass any function.
Yeah, it returns a string, but we defined it. The return type will be like it converts into the uppercase.
Right. Now we can also apply the shortcut here. We can, instead of this, I can, instead of the input parameter is nothing but underscore dot, yeah, instead of this, s is now underscore to uppercase. We can also apply the shortcut in this fashion. Either you do in this fashion, you define a function and pass it as a parameter, or you directly pass a function literal, or if you want to
Or
some more shortcuts.
This is an higher order function. String
Yes,
of
string of is
Java.
a higher order function. String of is a higher order function which is taking one more function as a parameter, and that function you can pass as a normal function, or we can pass as a function literal. This also we have seen, or we can just specify the data. You can just specify underscores.
So underscore means the first parameter. That is the Java, right?
That is nothing but a yes here, which is yes here. Now yes is nothing but yes is being used.
There is no fixed standard, right? So we can use anything. It is little like.
Right, we can use
So how do
anything.
we standardize
We
it?
can use anything. There is no.
So how do we no standard?
There is nothing called as a nothing standard. I have seen people using most of the time function literal. Wherever underscore is possible for simple expression, shortcuts are being used. Underscore also are also a lot of times underscore are being used for simple functions. Nothing kind of a shortcut here. So I can pass. I mean, instead of this, I can define some other function. Yeah, I think the audio is restored now. So we can just specify one more function as a parameter here. It will just reverse that. We passed uppercase function. We can also pass some other function also. Only thing is, it also needs to take a string and return a string. Reverse function takes a string and it returns a string. Hence reverse function can also be, I mean to say, you can pass any function. You can pass any function which takes a string and returns a string. I can just say define function concat. I can just say it takes a string and definition is s. I can just say hello space. So as you can see here, this function takes a string and returns a string. I can also pass this function also. So it just says hello and Java. You can pass any function, but only thing is the data type has to match. So that's the idea of using a higher order. The use case of higher order function is you can write a smaller function and you can achieve lot of things. It is kind of a more generic function now. With simple, I mean with less lines of code we can achieve lot of things. That's the idea of the higher order function. We can reuse our function for different purpose here. That's the main one of the use case of a higher order function. That's the reason Scala code is always much lesser than the Java code. Java codes are, I mean, whatever we could achieve with Java. Suppose the Java takes 100 lines of code, we can achieve the same thing with the probably around 20 to 30 lines of code using the Scala language. So that's our higher order function. Now let's use some more example here. Let me define a one more higher order function called simple ops. Now the simple ops takes three parameters. The first parameter is simple integer. Second parameter is also simple integer. The third parameter I want to pass a function, and what type of function I want to pass. And also one thing to keep in mind is it will be very rare that you yourself will be defining a higher order function. There are a lot of already defined higher order functions available in Scala as well as in Spark. It's already been defined. It would be very rare that we ourselves will be defining a higher order function. Most of the time we will be calling that higher order function, or we will be making use of those higher order functions. Just like this. We won't define a higher order function, but we will be making use of that higher order function in this fashion. Only if you are developing some library or framework or some complex thing where multiple problems can be solved with the single API, only then the higher order function makes sense. Otherwise, there are already existing lot of higher order functions. We have to come up with lot of problem statements, and whether it could be solved with only one function, then you design your higher order function. Otherwise, you just make use of the already existing higher order function. So let's say we have defined one more higher order function which takes two integers, and the third parameter, it takes a function, and that function takes two integers and it returns an integer. And the body of this higher order function is nothing but I just call that function, that's all. I just call that function. Whatever function I pass as a parameter, I just call that function in the body of higher order function. Only thing is it needs to take two integers. The function, whenever I call that function, it needs to take two integers. We know that x is an integer and y is an integer. We can always pass x and y. Whatever this function returns, the same thing is being returned from this higher order function also, because that's the last expression in the body of the higher order function. So that's the simple higher order function here. Now what type of functions we can pass here? We can only pass a function which takes us two integers, and it returns an integer. So I can define a function something like this. It takes two integers, and I will just say a plus b. This is a simple function sum total. It takes two integers and returns an integer. Obviously, this function's data type matches this parameter data type. Now we can pass this function as a parameter when we call this higher order function. The first parameter I will take as 4, second parameter is 5, and the third parameter is nothing but our sum total. So sum total will be passed as a parameter, and inside that function, higher order function, the sum total is being called here by passing 4 and 5, which returns 4 plus 5, which is 9. Similarly, we know that we need not define this function. We can directly use the literal of the function. We can directly use the literal of the function. And I can just say that's fine. It will give the same result. In a similar fashion, we know that the input parameters can be held in a underscore as a placeholder. Underscore can be used to hold the input parameter. So underscore, we can use that shortcut also here. We can just say underscore plus underscore. The first underscore represents x parameter, second underscore represents the y parameter, and x plus y represents the logic. So we should get the same.
So like we pass that in the reduce by key, right?
Right. This is
Underscore.
that's how the reduce by key works. We will see that when we.
Okay.
But all those things comes from the Scala language.
Okay.
So now we need not define this sum total. I can directly use this underscore plus underscore means the two parameters we are passing a function that takes. What does this mean is we are passing a function that takes two parameters and we are adding those two parameters. Similarly, I can just say minus. I need not define subtract function like this. I need not define. I can directly use the logic here itself and I can achieve the subtraction. I can also specify star. I need not define a product function and then pass it as a parameter. I can just use the shortcut and achieve the multiplication of two parameters. We are reusing the simple ops again and again for different usage. In a similar fashion, what will be the result of this? What will be the output of this? Right, right. Since it is a false or boolean, it should give a error. It must give a error because what we have defined our function, what type of functions we need to pass. We can only pass a function that takes two integers and returns an integer. But this function takes two integers and it returns a boolean. It returns so this function cannot be passed as a parameter. So it gives a compilation error saying type mismatch. Because it has found boolean but the required was return data type was supposed to be integer. Now how can I solve this problem? So how can I make my higher order function, which is a generic function? I mean, reusable function. How can I make it more generic? So we use the type parameter so that even these can be included in our higher order function. So how do I use mine? So we need to redefine our higher order function with type parameters. We know that we have already seen how to define a type parameter. Simple ops will take two different data types, type parameters a comma b, and I will say x is of type a, and I will say y is also of type a. The function takes two parameters both of type a. That function can return totally different data type, hence I will say it as b. So we will be passing two different, this signifies that this function can take two different data types, that is a and b. That's what this signifies. It can take two different data types. I mean to say, it doesn't mean it all things has to be input parameters. It can deal with the two different data types, I can say. It can deal with two different data types. The first two parameters are of the type A, and the function also takes the same data type as the parameters data type. If the parameters are integer, the function also takes an integer, but it can return some other data type also. It can return integer also, b can be integer also, b could be double also, b could be boolean also, or it could be anything. That's what we are making it as more generic. Sorry. Now again, as usual, I am calling this function with x comma y. So I can call this function. I can just say both are, a is also integer. I can say b is also an integer. I can just say 4 comma 5, and I can just use underscore plus underscore, because addition of two integer always returns an integer. So that should be fine. Similarly, I can use star. Similarly, I can use tract. Similarly, I can use greater than. Only thing I have to say is b type is boolean. So whenever I say it is a boolean, the definition of this function changes. The definition now says that you can pass a function f which takes two integer as a parameter because a is integer, and it can return boolean as the return type. So I can pass such function. Now this will also work fine. It says that 4 is not greater than 5. It says that 4 is not. So this is how we use a higher order function. This is how we use a higher order function. So I hope the things were clear. I hope the things were clear. It may require some more practicing. You can try these examples. The examples are available here. You can try all the examples. The placeholder syntax is this. Any kind of an operation we can pass here. We can define a function that takes three input parameters, and we can achieve it. And here is the data type. generics being mixed with the higher order functions, so we get a more generic operations. So if I want to do division, division should also be possible. Because division of two integers may not be a integer. So in that case, we have to specify double as the data type. That will also start working. So this is how we use a higher order function. Now the idea here is, what we have learned here is, initially we talked with the simple functions. We talked with simple functions, then we learned about function objects. There we also learned function literals. Then we talked about shortcut. Then we learned higher order function. We talked about higher order function. Now we know that use case of what is a higher order function. So we achieve a lot of things with few lines of code. That's the main one of the use case of higher order functions. We will see one more use case of the higher order function as we go forward. Drastically, the number of lines of code is reduced, and we achieve lot of things with a few lines of code. That is one of the, and we make it reusable. Same function is being reused again and again for different purpose. That is the use case of higher order function. Now next what we'll do is we will learn collections. We'll learn collections and later how higher order function is applied on collections. Most of the higher order functions are defined on a collection. This is very important. Higher order functions on collection. This is the main thing to be understood with respect to higher order functions and collection, because the same thing is applied in Spark also. Spark also does the same thing. Here is a question. Using higher order function is advantage. However, how about performance of using such function? I mean, there is no difference in the performance. It is as good. I mean, there is no increase or decrease in the performance. It does not affect the performance at all. Performance doesn't come into picture here. Either you write a normal Java program or you write a Scala program, you should achieve the same performance. A function written in Java or a function written in Scala, any function, simple function you write or a normal higher order function you write, you should achieve the same performance. There should not be. Only thing is, there will be lesser code. Maintaining of the code will be lesser now. Less code to maintain. So I hope, Mohan, that was clear. So let's understand simple collections. Mainly we will be talking the collections also in the form of higher order function. Mostly we'll be talking about different higher order functions when we discuss collections. So we can just look into the hierarchy of a collection. So it is a bigger one, but we may not be looking into everything. So as you can see, the parent class is traversable. After that, we have the iterable. Hence, I was always trying to say that for loop takes an iterable. And I said that iterable is nothing but a collection. So for loop always takes a collection. There are, I mean, three different types here: sequence collection, set collection, and map collection. Map is nothing but hash map. It's in the form of a collection of key value pairs. Set is nothing but a unique collection of elements. Will be no duplicates in sets. Now sequence is again a generic collection where we have two different kinds of collection: indexed sequence and linear sequence. Again, this will keep on growing. You can see sequence, under that we have indexed sequence, linear sequence. We saw vector collection. Vector comes under index sequence. Numeric range. We saw the range collection like 1 to 10. That also comes under index sequence. String also comes under indexed sequence. List, stream, queue, stack comes under linear sequence. Now what is indexed sequence and what is linear sequence? So that we will discuss. That we will. So as I said, we are seeing here that list is a linear sequence. As you can see, is a sequence is just like we say sequence of elements. So that name has been taken there, sequence of elements. So we said that list is linear sequence. Now why do we have such a category? Why do we have such a category as linear sequence? Now list is nothing but the way you create programmatically, the way you create a list is in this fashion. So programmatically this is how we create it, but internally how it is implemented, internal implementation is something like this. So this is how internal it is implemented. It is implemented in the form of single linked list. So that's the reason it comes under the category of linear sequence, because because let's say there are, here I'm having only 4 elements. Let's say there are 100 elements. If you want to access 50th element, so how I can access the 50th element? I have to start from the first element, traverse through all the elements up to 50th element, only then I can access. So I have to traverse in a linear fashion. So that's the reason it is called as a linear sequence, because we have to traverse in a linear fashion to access any randomly chosen element. If I want to access after that 30th element, some randomly chosen element, again I have to start from the first element, traverse linearly across all the elements up to 30th element. That's the reason it is called as a linear sequence. Again, if I want to access 80th element, again I have to start from the first element and traverse linearly and go to 80th element. So I have to traverse up to 80 traversals I have to make. Here 30 traversal I have to make. Here 50 traversal I have to make. So that's the reason it is called a linear sequence. So linear sequence is not good for random access. So if you are accessing your collection randomly based on some index, I want 30th element, 50th element, based on that if you are accessing your collection, in that case list is not good. List is not good for random access because list comes under linear sequence, because every time we have to traverse lot of nodes. So if you are going through every element, if you want to access every element from the first element to last element, then it's good for, then list can be used. That use case list can be used. If you are only randomly access one or few elements, randomly access, first you will access 50th element, then 30th, then 4th element, then 25th element, then 100th element. If you are randomly choosing some element to access, list is not good for that. List is only good for the use cases where you access every element in a sequence. First you access the first element, then the second element, then third element, then fourth element. So if you are accessing every element, then list is good. In such use cases, list is good. We have seen our transformation, if you remember, for and yield. What does for and yield do? For takes a collection, transforms each element to something else. In that case, we will be going through every element of the collection. So in such cases, wherever you want to do the transformations, linear sequence are good, but they are not good for random access. For random access, indexed sequence are good. We'll see that why. Index sequence is
Good linear sequence. Pramod?
sorry,
A linear sequence is good for which?
for accessing every element.
Sequentially, right?
Right, sequentially when we are accessing every element, linear sequence is good. So if you remember, if you remember, for some list 4, 5, 6, 7, we yield something and we say I plus 1. So here we are accessing each element from first to last. We are doing a transformation. We are doing a transformation for each element. There a list kind of a collection will be good, because we are not randomly accessing. We are accessing every element in that, from the first element to the last element in one sequence. So list becomes good in that. So the way you define a list collection is in this fashion. I can just say val nums is equal to list of I can say val colors is equal to a list of I'm having a collection of strings. It is automatically inferring the data type of a string as the data type of the colors is string. The data type of nums is integer. Based on what value you pass, what value the collection is all about, the data type is automatically inferred here. We don't have to explicitly say that. Similarly, I can have a list of users. I can just say val user1. I can just say val user2. If this is a tuple, I can just say val user3. Do I have val user4? No, it's something different. Then I can also have a collection of, I can have users, val users is equal to a list of user1, user2, and user. Here also it has automatically inferred that this collection is a collection of tuples. Collection of tuples. Individual tuple data type is integer, string, integer, string. Those has been automatically inferred here. So this is how you define a collection. And I also said that collections are by default immutable in Scala. I mean, you cannot modify the content of a collection. There is no such method exists to modify because everything is an object here. We know that nums is an object, colors is an object, users is also an object. So any operation you want to do an object, it has to be through a method. So there does not exist a method to modify this collection. They don't allow because Scala collections are immutable. We can add a new element. We can drop an element, but it will not modify the original collection. The original collection remains as it is. Remains as it is. So there are methods like I have nums here, right? So to access the elements, first element if I want to access, I have to just say nums of 0. The second element, nums of 1. The syntax is slightly different. In other programming language, we usually use square brackets. But here we are not using square brackets, we use parentheses. Parenthesis is used because to give us a significance that it is a function. Actually what happens, internally it is calling a apply method. We don't need to, as of now, just remember that internally an apply method is being called. Internally an apply method. We will see this later. Whenever we say nums of 0, the compiler internally calls a method called apply, passes the index, and we are able to access the index. I mean, whenever I say nums of 3, and it actually calls the apply method and passes that index, and we get the value. Actually, it is traversing. Internally, it is traversing, but the API given to us is through the index. Now I can, there are other methods as well. There is a method called head, which returns the first element of the collection, which is 4. I have a method called tail, which returns all the elements except the head. So we can use that. These are all the basic methods that are available on a collection. Similarly, there is a method called last. There is a method called last. Last gives you the last element. In a similar fashion, there is something called as init. Except the last, it will give the rest of the elements, 4, 5, and 6. Now there is one more method called as nums.take. The take, what it does, it returns first 2 elements of the collection. I can store it somewhere else also. Val x is equal to take first 2 elements of the collection. There is something called as take right, which returns last 2 elements of the collection. Similarly, there is something called as drop. Just like take returns first two elements of the collection, drops the first two elements of the collection and returns the rest. It returns the rest. 4 and 5 will be dropped. 4 and 5 will be dropped from the collection, and remaining is nothing but 6 and 7. So this method will return 6 and 7. Similarly, drop right drops the last two elements of the collection and returns whatever is the remaining. So even though we did all these operations, nums did not get modified at all. Nums is still 4, 5, 6, 7. The original collection remains as it is, even though we did drop the first two elements. Actually, what it does is it creates a new collection by dropping the first two elements. Here also it creates a new collection by dropping the last two elements. So these are the simple operations that are available on the collection. Many other operations are there. You can always know what all methods are available. Here these are all the methods. Take is a method, take right is a method, drop is a method, drop right is a method. Similarly, there are many other methods. You can know which all methods are there by just typing dot and press the tab button. Press the tab button, you should see all these are methods. Most of the methods even I haven't used, but wherever the need arises, I use the. So if you see, symbols are also method. This is also a method. This is also a method. This is also a method. All these things are methods. We will see some of the methods defined here. And we'll also see some higher order methods that are defined on this collection. Our main purpose is to understand how the higher order functions are defined on these on the collections. We saw simple methods, but our main goal is to understand the higher order functions on this collection. That we'll look in tomorrow. So shall we wind up the session here and let's continue tomorrow same time.
Thanks, Pramod.
Thank you.
Thank you everybody. Let's meet tomorrow same time.
Thank you.